Imagine a world where contracts execute themselves without the need for intermediaries. How does that change our understanding of trust? This is not just a fanciful notion, but a profound shift brought about by smart contracts. These self-executing contracts, with the terms of the agreement directly written into code, create a new paradigm for how we engage in transactions. Unlike traditional contracts which rely on a trusted third party to enforce compliance, smart contracts operate on blockchain technology, ensuring that once conditions are met, actions are automatically executed. This automation not only streamlines processes but also drastically reduces the costs associated with contract enforcement. Think about it. No more lengthy negotiations with lawyers, no more waiting for checks to clear, and no more uncertainty about whether all parties will hold up their end of the bargain. Now, let's consider the implications of this shift. In a traditional contract, trust is often a fragile thing. It relies heavily on the reputation of the parties involved and the legal frameworks that hold them accountable. But what if trust could be encoded in software? This is one of the fundamental advantages of smart contracts. They eliminate the need for intermediaries by ensuring that contractual obligations are fulfilled through automated processes. When you send a payment via a smart contract, the code verifies that all conditions are met before allowing the transaction to proceed. This reduces the risk of fraud and errors, creating a more secure environment for financial interactions. But while the idea of trustless transactions is revolutionary, it also raises questions. What happens when different smart contracts need to interact with one another? How do we ensure that these disparate systems can collaborate effectively? Here we find ourselves at the heart of the inquiry into interoperability, an essential feature for a decentralized financial landscape. Imagine a scenario where one smart contract can seamlessly engage with another, regardless of the underlying blockchain technology. This interoperability not only enhances functionality, but also opens doors to new financial opportunities. As we begin to unpack the functionalities of smart contracts, we see that they offer unique advantages that traditional contracts simply cannot match. They provide transparency, as every transaction is recorded on an immutable ledger, and they can be programmed to maintain a detailed history of interactions, akin to a digital receipt. This capability not only strengthens trust among users, but also lays the groundwork for an efficient, decentralized financial ecosystem. So, as we delve deeper into this world of automated agreements, we must ask ourselves, what trade-offs might we encounter? And who stands to benefit or lose as we embrace this new frontier of trust? What if your smart contract could seamlessly interact with another, regardless of its underlying blockchain? Imagine a bustling marketplace where vendors from different regions can trade with each other without needing a common currency or a middleman, each relying on their own unique systems, yet able to transact effortlessly. This is the essence of interoperability between smart contracts, a concept that, while still evolving, holds the potential to revolutionize our financial systems. As we dive into this fascinating realm, let's consider some very practical mechanisms that enable diverse smart contract systems to communicate and collaborate. One of the most prominent methods is the use of bridges, not the physical structures we cross over rivers, but digital conduits that connect disparate blockchains. These bridges allow for the transfer of assets and data between different blockchain environments, enabling a fluidity that was previously unimaginable. For example, suppose you have a decentralized application on Ethereum and you want to access liquidity from a different blockchain like Binance Smart Chain. With a bridge, you can move tokens from one chain to another, unlocking new possibilities for your smart contract. The strange consequence is that this not only enhances the utility of individual contracts, but also fosters a more interconnected ecosystem, where applications can leverage each other's strengths. However, the implementation of bridges isn't without its challenges. Security is a paramount concern. What happens if the bridge is hacked, or if the token transfer process fails? This leads us to another critical interoperability mechanism, oracles. Oracles serve as external data feeds that provide smart contracts with real-world information, which can be essential for executing transactions based on external conditions. Imagine a smart contract that automatically executes a trade based on weather data. If it rains, the contract might trigger a payout to a farmer. By integrating oracles, smart contracts can react to changes in the environment, enhancing their functionality beyond mere code execution. But here's the question: how do we ensure that the data provided by oracles is reliable? This is where trust mechanisms play a crucial role. Without a reliable way to verify the data from oracles, we risk undermining the entire system's integrity. So, what trade-offs emerge from these interoperability methods? On one hand, we gain enhanced flexibility and opportunities for collaboration. On the other, we introduce complexities in security and data verification. As we think about these mechanisms, let's also consider their implications. What if, as smart contracts begin to collaborate more effectively, we see a shift in how value is created and exchanged? Decentralized finance could evolve into a more robust ecosystem where innovation thrives on collaborative efforts rather than isolated functionalities. The question lingers in the air: who benefits from this interconnectedness and who might lose out? Will established systems adapt, or will they be left behind as new interoperable solutions take the forefront? As we navigate this intricate landscape of collaboration among smart contract systems, the stakes are high. The potential for a more efficient, transparent financial ecosystem beckons us to explore further. But the path forward requires a careful balance of innovation, security, and trust. Imagine two independent smart contracts, each residing on different blockchains, yet both are engaged in a complex financial transaction. How can they trust each other to execute as intended, without a central authority or a mutual intermediary? This question lies at the heart of collaboration among smart contract systems. The key to unlocking this trust is through robust trust mechanisms, and one of the most powerful tools at our disposal is cryptographic proofs. These proofs act like digital fingerprints, allowing each contract to verify the integrity of transactions without needing to rely on the other party's word or reputation. Let's consider a scenario where one smart contract represents a decentralized lending platform while the other manages an insurance protocol. When a borrower takes out a loan, the lending contract needs assurance that the insurance contract will honor a claim in the event of default. To facilitate this, cryptographic proofs can be used. The insurance contract can create a hash of the loan agreement and store it on the blockchain. When the lending contract queries the insurance contract about the validity of the claim, it can check this hash against its own record. If they match, trust is established based on mathematical certainty rather than human judgment. This trustless environment is a cornerstone of decentralized finance, where reliability is built into the code itself. Each smart contract, fortified with cryptographic proofs, can autonomously validate the actions of others. Imagine a world where financial transactions are executed seamlessly, with each participant confident that their interests are safeguarded through code. However, this raises an intriguing implication. What happens if a bug or exploit is discovered in one of these contracts? The strange consequence is that while cryptographic proofs can enhance trust, they cannot eliminate risk entirely. If a vulnerability is present, it can compromise the entire collaboration, leading to significant financial losses. Thus, the collaboration between smart contracts is not just about establishing trust. It's also about ensuring that the mechanisms for creating that trust are foolproof. This intertwining of trust mechanisms and risk management becomes a delicate dance. As we delve deeper into these interactions, we must consider who benefits from these innovations. Developers gain the ability to create more sophisticated financial products, while users enjoy increased security and efficiency. But what of the traditional financial systems that rely on human intermediaries? They may find themselves at a disadvantage in this rapidly evolving landscape. So as we ponder the future of finance, we must ask ourselves, how can we refine these cryptographic mechanisms to enhance collaboration while minimizing risk? The pursuit of a truly interoperable financial ecosystem continues, and the role of trust will undoubtedly evolve alongside it. What if the future of finance was built on trustless systems that operated without intermediaries? Imagine a bustling city where every transaction, be it a simple payment for coffee or a complex investment in real estate, could occur in a matter of seconds, with no banks, brokers, or other middlemen taking a cut or introducing delays. This isn't just a dream of a more efficient financial ecosystem, it's a tangible possibility presented by the interoperability of smart contracts. Imagine two people, Alice and Bob, wanting to trade assets stored on different blockchain platforms. Currently, they would need to navigate a maze of exchanges, facing delays, high fees, and the ever-looming risk of fraud. But what if their smart contracts, each coded to operate within their respective systems, could communicate seamlessly? This scenario is a glimpse into how interoperability can transform financial systems by reducing transaction times and costs. As these smart contracts interact, the barriers that traditionally hinder financial exchanges could dissolve, allowing for a more fluid marketplace where assets can move with ease. In this interconnected web of financial interactions, transparency becomes a cornerstone of user trust. Each transaction, logged immutably onto the blockchain, serves as an irrefutable record, visible to all participants. This transparency means that users can audit transactions at will, gaining confidence in the integrity of the system. In contrast to traditional finance, where hidden fees and opaque practices often erode trust, an interoperable framework built on smart contracts could foster greater user confidence. But this raises an important question. How do we ensure that these systems remain secure as they become more interconnected? As we explore the potential of interoperable smart contracts, we must consider the implications of increased transparency and the responsibilities it entails. With everyone able to see every transaction, how do we protect sensitive information? The strange consequence is that while transparency can enhance trust, it also demands a new level of sophistication in how we manage privacy and security. Now, let's think about the implications for existing financial institutions. If smart contracts can perform the functions of banks, brokers, and payment processors without the need for human oversight, what happens to these traditional roles? Some might argue that the rise of decentralized finance could lead to the obsolescence of established financial structures. Yet others might contend that there's a symbiotic relationship to be forged. Perhaps traditional institutions will adapt and integrate these smart contract systems into their operations, enhancing their service offerings while reducing costs. As we ponder these possibilities, it becomes clear that interoperability is not simply a technical challenge, but a fundamental shift in how we perceive finance. It invites us to rethink trust itself, no longer merely a function of human oversight, but a system of code and consensus. What if trust could be engineered, built into the very fabric of financial transactions? This could lead to a recalibration of power dynamics within the financial landscape, where users reclaim control over their assets and transactions, free from the constraints imposed by intermediaries. However, we must also consider who benefits most from this shift. Will it be the small investors who can transact freely at lower costs? Or will larger entities find ways to leverage interoperability to their advantage, creating new forms of monopoly? The trade-offs are significant, and as we venture further into this landscape, we must remain vigilant about the implications of this technological evolution. As we move towards a future governed by interoperable smart contracts, one thing becomes clear. The essence of trust will not only evolve, but will be redefined by the very systems we design to enhance transparency and efficiency. What might this mean for our understanding of value, risk, and even our relationships with money itself? Imagine a world where every transaction, every contract, and every financial interaction is backed not by a central authority, but by lines of code that you can trust. As we venture deeper into a decentralized future, the question of trust becomes more nuanced. In this landscape, what would happen if our understanding of trust evolved from relying solely on human intermediaries to embracing the transparency and security of smart contracts? Picture two smart contracts, each on their own blockchain, seamlessly executing a transaction without needing a bank to confirm it. The strange consequence is that trust shifts from the institutions we've always relied on to the very code that dictates how these contracts operate. This is the essence of interoperability, the ability of disparate smart contracts to communicate and collaborate, creating a financial ecosystem where trust is built into the fabric of transactions. Now let's consider the implications of this shift. Traditionally, trust has been a social construct cultivated through relationships and reputations. In a world powered by interoperable smart contracts, trust morphs into a different entity, one that is quantifiable and transparent. Each interaction is recorded on a blockchain, creating an immutable history that can be audited by anyone at any time. This level of transparency could lead to a dramatic reduction in fraud and errors, as every party involved has access to the same information. But what happens when trust is purely algorithmic? Can we truly rely on code to capture the complexities of human behavior and relationships? As we explore this evolving landscape, we must also confront the challenges that accompany it. For instance, while interoperability promises enhanced efficiency, it also introduces new vulnerabilities. If one smart contract is compromised, could it expose others to risk? The decentralized nature of this new system means that accountability becomes more diffuse. Who is responsible when things go wrong? In this context, new mechanisms of trust may need to emerge. We can see the rise of decentralized autonomous organizations, or DAOs, which could govern the interactions between smart contracts, providing an additional layer of oversight and accountability. But how do we ensure that these DAOs themselves remain trustworthy? Moreover, the complex algorithms that underpin these smart contracts are not immune to bugs or exploits. Imagine a scenario where a small oversight in the code leads to a significant financial loss for users. This brings us to the importance of rigorous testing and audits in the development of smart contracts. As we shift our trust from traditional institutions to code, we must also invest in the tools and practices that ensure this code is secure and reliable. The balance between innovation and security is delicate, and navigating this terrain will require collaboration among developers, users, and regulators alike. As we ponder these transformations, let's reflect on who stands to gain and who might lose in this new paradigm. Financial institutions that adapt and integrate with interoperable systems could enhance their services, but what about those who resist change? The potential for disruption is profound. In a world where transparency reigns, traditional banks might find themselves at a crossroads, needing to rethink their roles in this new financial ecosystem. So, as we continue our exploration of interoperability and its implications, we find ourselves asking, how will our understanding of trust need to adapt in a landscape where code, not people, dictates our financial interactions?